Hello, my name is Melanie Arajava,
And I'm Sophia Chireo.
and our project this summer was about the effects of TAC on human fold signal during motion adaptation. So hopefully by the end of this you kind of have an idea of what we're talking about.
So our first objective was how does TACS interact with the human brain? And TACS is transcranial alternating current stimulation. And pretty much what this is you have a stimulator box that has two wires connected to two electrodes, and these two electrodes are placed on a person's brain, and they deliver a low-intensity electrical current to that person's brain.
So how do we study the human brain? We use an fMRI machine here to our left, and our main question throughout our entire experiment was, what happens to the motion areas to the brain when we apply TACS? Here is from previous experience, we know that motion adaptation is correlated to this area of the brain known as MT, also known as V5. Our experimental paradigm consisted of two gratings of fixation point, and in this case this was our adapter, and it's known as an adapter because it was shown for a long period of time. In this case our adapter is moving outward, following either a test moving in the same direction or in the opposite direction.
So what we saw from this was that when the opposite test was shown, the gratings moving in the opposite directions, there was a higher response because during the adapter, the gratings are moving in the opposite direction. So when the test in the same direction is shown, there's a lower response. And when TACS was applied, we saw that the response was negative because now there was a higher response for the same test, which showed that TACS reduced the effects of the adaptation.
So in conclusion, we successfully replicated our previous findings, and from our results we can conclude that TACS does reduce the adaptation-induced changes in fold signal, specifically in the left hemisphere.
And the connection to the world is that electrical stimulation has many uses. For example, it's used to train soldiers, specifically airmen, with coordination. It's also used to improve symptoms of ADHD and ADD in people. And it's used to treat Parkinson's disease patients. It's used to treat people with depression and people with chronic pain.
But we don't have enough knowledge about the electrical stimulation and how it interacts with the brain. So we studied the mechanisms of the electrical stimulation, and hopefully it would help ultimately to optimize this technique. And we would like to give a round of applause to the Kreckelberg Lab at Rutgers University, and thank you for Liberty Science Center for providing us with this opportunity.
We'd also like to specifically thank our mentor, Koletich Carr, for tremendously helping us in understanding all this material.